How much water is available in the global water cycle? Of all the water on the Earth, only 2.5% of it is fresh. Of the fresh water, 68% is in ice caps and glaciers. 30% in groundwater, and only 1.2% is surface water. How does this water flow? Roughly 413,000 cubic kilometers is evaporated by the sun every year. 373,000 cubic kilometers of which falls right back into the ocean, while only 40,000 cubic kilometers per year reaches the land as precipitation. Another 11,000 cubic kilometers evaporates from the land and precipitates back down. But plant life does even more, placing 62,000 cubic kilometers back into the atmosphere, which precipitates over land again. In other words, 90% of the water evaporated from the ocean never makes it to land. But once on land, the water is likely to evaporate or transpire and return to the land again as additional precipitation. Still, looking at the entire amount of fresh water produced by the sun, 10 times more water flows from the ocean up into the atmosphere by evaporation than through all the rivers on Earth combined. This is equivalent to 75 Mississippi rivers flowing from the ocean up into the sky continuously all year round. But only 8 of them deposit their water over the land. How can we improve these water cycles? Let's examine 3 ways: desalination, weather modification, and surface water transfer. First, desalination. Did you know that the ocean is the source of all your fresh water? About 60 million gigawatts of power from the sun reaches the ocean's surface, desalinating 413,000 cubic kilometers of fresh water per year. This is an average efficiency of 1,300 kilowatt hours of energy per cubic meter of fresh water produced. Mankind, however, using reverse osmosis desalination, only needs 3 kilowatt hours of energy per cubic meter, making mankind 430 times more efficient than the sun when it comes to the production of fresh water. power requirements to desalinate water for the major coastal cities of California would only be 50 watts per person for the state, providing 2/3 of current public use, and 10% of the water needs of the entire state when we include agriculture and other uses. How could desalination add to the global water cycle? A second way to improve the water cycle: weather modification. Recall that 413,000 cubic kilometers of water flows from the oceans into the atmosphere annually, 10 times the 40,000 cubic kilometers flowing through all the world's rivers. This is an immense resource waiting to be developed. For decades, atmospheric ionization systems have been successfully used to stimulate the condensation of atmospheric water vapor, increasing precipitation. One version of atmospheric ionization technology was developed in Russia in the mid-1980s and brought to Mexico, where commercial operations from the late 1990s to 2008 resulted in 5 to 50% increases in precipitation in entire states, the filling of reservoirs, and the reduction of forest fires. In Israel, operations from 2011 to 2013 filled 7 reservoirs to their full capacity, for the first time in the 40-year operation of the reservoirs. A second version of atmospheric ionization technology was developed in Switzerland and was then utilized in the United Arab Emirates. Trials with these systems in Australia from 2007 to 2010 consistently increased precipitation between 10 and 20%, and a 5-year trial program in Oman, starting in 2013, has increased precipitation by 18% during the first 2 years of operation. Let's see how ionization could add to the global water cycle. A third way to improve the water cycle: surface water management, typified by the North American Water and Power Alliance. In the western half of North America, the distribution of fresh water is wildly uneven, creating a great western discrepancy. This can be seen when comparing the average annual discharge of the rivers of the Northwest with the average annual discharge of the rivers of the Southwest. That's 1,509 cubic kilometers per year for the North versus 113 for the South. Same continent, same coast. How can we address this great western discrepancy? The Nawapa 21 project would be the largest water project in world history, diverting water from the northwest, where it exists in abundance, into the southwest, where it is desperately needed. An updated version of the program could transfer roughly 10% of the northwestern discharge, 150 cubic kilometers per year, down throughout the southwest, before that water returned to the ocean. The addition of this amount of water could double the photosynthetic productivity of the Southwest, increasing the productivity of the entire cycle without changing the net volume of its flow. Taken together, desalination, weather modification, and surface water transfer come together to enable an improved and expanded water cycle. With an integration of these methods, mankind can increase the productivity of existing cycles, enlarge existing cycles, and create entirely new ones. None of this is using up finite water supplies. Instead, it is a better management of the cyclical system. Don't let anyone tell you otherwise. The water exists. Let's develop it. How much water is available in the global water cycle? Thousand cubic kilometers is evaporated by the sun every year. 373,000 cubic kilometers of which falls right back into the ocean, while only 40,000 cubic kilometers per year reaches the land as precipitation. Another 11,000 cubic kilometers evaporates from the land and precipitates back down. But plant life does even more, placing Of the fresh water, 68% is in ice caps and glaciers. 30% in groundwater, and only 1.2% is surface water. How does this water flow? Roughly 413 Of all the water on the earth, only 2.5% of it is fresh. 2,000 cubic kilometers back into the atmosphere, which precipitates over land again. In other words, 90% of the water evaporated from the ocean never makes it to land. But once on land, the water is likely to evaporate or transpire and return to the land again as additional precipitation.